Okay, so let's take a look at number one and number two here. So you've got this contingency table up the top that has the rows have the gender and the columns have how much importance religion has for them. So the first column, for example, represents that these people have don't see religion as important at all. All right, now in question one, we want to use this contingency table to create another contingency table based on column totals. So we are going to make percentages based on the column. All right, so what we're going to do is only look at this column, this first column, as we do the not part. And I'm just going to do one column and then I'll leave the fairly column and the very column up to you. All right, now, so there are 32 males out of a total of 63 people in this column. So what we're going to do is just take 32 and divide it by 63 in our calculator, and that gives us 0.5079. I don't think I said how many decimal places to go to, so we'll just call that 0.508 when it's rounded. All right, let me see if I can actually draw on here for you. Maybe. Okay, I did manage to put it in the cell, although it's somewhat like a first grader. All right, now we'll do the same thing for female. We'll take the 31 females and divide by the total of 63. And that is 0.492. And because I am drawing like a first grader, I'm going to kind of put it out here and put an arrow. Uh, so that actually goes in that cell right there. And then for the total, these two should add up to one. Oh, something I forgot to do was to go ahead and change them into percents. So this is really should be 50.8% and 49.2%. So notice we do the division, we get a decimal, and then we'll move our decimal places. And so this really should be 50.8 and 49.2. And then you'll do the same thing for the fairly column and the very column. All right, now, so question number two says for the table you created in question one, identify and explain what the percentage in the first cell, male and not religious, means. Okay, so we had 50.8% of men who, these are men who do not see religion as important. So of the people who, we can think of it as of the people who are not interested in religion, 50.8% of them are men. Or we could say these people are males who do not consider religion important. Okay, so 21. I may have to get out of whatever the draw feature is here. Let's see. Okay, so for 21, we need to follow the directions for the lab in order to be able to answer this first question. So I'm going to go back up here and we're going to create a contingency table using stat tables contingency with data with a row variable of gender and a column variable of car, and we're going to select row percent and click compute. So I'm going to go to StatCrunch. Now the one thing you need to make sure of is that you're in the group and then you're going to go to the data sets. So you want to be in the data sets and you'll see this one sitting here. So I will click on that and it's just going to pull it up. Now we are going to go to stat and then contingency tables. Let's see, summary stats. No, what did it say? All right, stats, then tables, and then contingency. And we're going to do this with data. Okay, so row variable, it told us to choose gender. So there it is. And column variable, it told us to choose car. All right, and then for display, we wanted row. So we're going to click on row there, and then we're just going to go down to the bottom, which is slightly hard to see. Let me see if I can expand the window. There we go. And we see the compute button. We're not going to care about anything else. We're just going to click compute, and it gives us the percentages, the row percentages in there. All right, now we don't care about this chi-square test down here. That has nothing to do with what we want. All right, so we've got this information right here. Now this is just the row contingency table. For the column contingency table, I would have done the exact same thing, except under that display, that last thing I chose, I would have chosen column. So let's go back to the page where we wanted to answer 21. So explain how the percentage is interpreted in each of these cases. So percentages based on row totals. All right, so let's look back at this for a second. I'll go back over here to our results. So this row total right here for these 8 females in this row, okay? Of all of the females, if we look at the females, 20, almost 21%, but 20.5% of the females have a black car. Or we could say 5.1% of these females have a blue car. Or if we look at the row here, this is all males. So of these males, 12.5% have a black car, and so on. Now, for columns, we'd be looking at of the black cars, that many of them, whatever it ended up being, would be female. So you just have to think of what is the column describing of that group. This many are female or whatever it might be. So in this case, our group is the row because we're looking at the row of the females. 20.5% have black cars. Hopefully that will help you with that. All right, now I'm going to go on to your second portion of your questions in 2D. Okay, so your question here was on 6 and 7. So let's remember a couple of things when looking at a correlation matrix. We're going to use a rule of thumb of 0.7 or greater is a pretty strong linear correlation, or negative 0.7 or less is a pretty strong negative linear correlation. So if we look at education versus income, that's a 0.885. That's bigger than 0.7. We'll consider this a strong positive linear correlation. So strong positive linear correlation. So that's what we're looking for in number 6. Number 7, debt versus murder. Okay, so debt and murder is out here. Okay, it's 0.03. That's almost 0. Anything really close to 0 is a very weak linear correlation. This one is positive, but it's weak. So this is a very weak positive linear correlation. We can almost say there's really no linear correlation here because this is so close to being 0. All right, now I'll flip down to the next one. Okay, for these next ones, we're going to use StatCrunch, and we're going to follow the directions that are right here. Stat, summary stats, correlation, and we're going to select all of these variables in the column and then hit compute. And then we'll be able to answer those next questions. Now, I'm going to answer one of them, which I think is going to help you to answer all of them. So let's go to our student survey data. I'm just going to get rid of this stuff we had before. And the window is a little small. I'm going to see if I can move it back up. There we go. All right, so we're going to hit Stat, Summary Stats, and we're going to go to Correlation. And I want to, and again, maybe I need to move that window again, just so you can see all of this. Okay, so we're going to select the columns time, and it tells me if I hold control down, I can click on the others. So height, shoe, sleep, work, TV, temp, classes, money, and heart. And then we're just going to go down and hit compute, and it gives us the correlation matrix. All right, now, here's our matrix. We'll come back to it as we answer the question, but let's take a look at what you had, number 19. How many pairs have a strong linear correlation? So we remember we said strong as our rule of thumb is 0.7 or greater or negative 0.7 or less. Okay, so going back, we're looking for any of these where we have a number's absolute value that is greater than 0.7. And sure looking like none of them do, although I can't quite see all of it. Okay, so 0 have a strong correlation as we look across there, unless I'm missing one. Looks to me like none of them are bigger than 0.7 or smaller than negative 0.7. This one is getting close, but it's still not quite strong. It might be moderate strength at 0.6. All right, so let's go back here. All right, so 0 of them have really a strong linear correlation. What pair has the highest correlation coefficient? That was that 0.6. So if we look at what that pair was, that was shoe with height. Okay, and that makes sense that that would have a stronger linear correlation, your shoe size with your height. Okay, so it has a correlation of 0.6049. All right, so let's go back. What is the value of the highest correlation coefficient? That would be that 0.6049. Now, let's realize in number 20, it's asking exactly what that one is. And then, does it indicate a positive or negative relationship? It's positive. And does it indicate a strong relationship? No. It's moderate, but it's not especially greatly strong. We're going to consider zero point 0.7 to be our rule of thumb there. And same idea for 21. Okay, so that's that. Let me see what your next question was. I may have to start a new video, but we'll see. Okay, so I've only got about 2 minutes left on my video, but I think we can answer the first part of this, and the rest of it I'll just put in the email because it shouldn't be too difficult after that. All right, so let's do exactly what this says. I'm going to go to this. I'll get rid of this correlation mode, and I'm going to do stats, and I'm going to go to regression, simple linear, and I'm going to put in the x variable is the height, and the y variable is the shoe, and hit compute, and it is going to give me an equation. And this equation right here, I'm calling shoe my y. So I really have y equal this right here, negative 4.9757749 plus 0.20825882, and the height I'm going to call x. So that is my regression formula. So as I get ready to answer the question back here, 23, I am simply going to put 64 inches in for x in that equation and put it into my calculator. Now I'm just going to do that in the email because my video is running out of time. And that'll give you the idea of what to do for 23 and 25, where you're just going to do it for two different variables.